Morning, everyone. Did everyone try this? Anyone got an answer? Let's see how this goes. Now, so when you take A, B, and C at any instant, so they are forming this triangle. So if you resolve the velocities into components, so no matter how much they rotate, you'll notice something, the centroid will remain same. Agreed? And now if you look at the velocity components, you'll have one component, this is 30 degrees, you'll have u cos 30 towards the centroid, u sin 30 tangential. Similarly, if you look at C also, u cos 30, u sin 30. U cos 30 and u sin 30. So this is how the velocities will be there. Make sense? Now, if you look at this clearly, who is making the triangle rotate? The sine components. So this sine components are the tangential velocities. This is your v tangential. And this u cos 30 is v radial. So u cos 30s are responsible for decreasing the distance and u sin 30s rotate the vector. So u cos 30 decrease OA bar and u sin 30s rotate OA bar. So initially, if you try to find the distance OA bar, so initially, how much is OA? I hope everyone knows this. A centroid divides the height of a triangle in the ratio 2:1. This I told you before also. If this was O and this was A, this will be 2/3 of height, 2:1 ratio. That is 2/3 root 3 A by 2, A by root 3. So O initial is A by root 3. Now after time t will be, now look at this thing, who is decreasing you? The one who is decreasing you. So this is A and your velocity towards O is u cos 30. Means as time passes, your A won't be constant here. So this would be A by root 3 minus u cos 30 into time. Is that making sense? You get closer and closer and closer. So the distance between O to A is decreasing. What is angular velocity? Angular velocity is v tangential by r. So here v tangential is u sin 30. That guy is constant. But r is nothing but OA. So you get u sin 30 by A by root 3 minus u cos 30t. This is the catch. So while finding omega, v tangential is remaining constant, but the distance is changing. That means the closer you get, the faster you will rotate. So as you're getting closer, you're rotating faster and faster and faster. Omega is not constant. Please have a look at the steps. And how do you have to find omega? What did I ask you? Find theta as function of time t. You tell me. Till now, whatever we did, is there any, there is only one place you saw theta and time together. D theta by dt is omega. That means somehow if I can find omega as function of time t, I can integrate and get it. Please have a look at this page. Everything that I told you here, you know. You know what u cos 30 does. You know what u sin theta does. And you know v tangential by r is omega. The only thing is you have to bring them together. Have a look at this page. Any doubts? Anyone not convinced with anything in particular, please ask. Clear? Question still not over. So we got omega from here. U sine 30 by a by root 3 minus u cos 30 into time. Simplify this further. This would be u by 2, a by root 3, u cos 30 is root 3 by 2 into t. This will be u by 2a by root 3 minus u root 3 into t. So root 3 will go up. You end up with 2a minus 3ut. Omega is nothing but d theta by dt. And now in case you forgot, dx by ax plus b ka integral, quite a useful integral, comes a lot, is 1 by a ln ax plus b. You should know this thing. You did this thing in calculus if you remember. Don't forget this. It's a very common integration in physics. So now when you integrate this, you will get d theta by, this would be root 3u dt by 2a minus 3ut. Integral, this goes from 0 to theta, this goes from 0 to t. This will be theta, this will be root 3u. So a ka place mein here is minus 3u. So minus 1 by 3u ln 2a minus 3ut integral 0 to t. U will cancel. You end up with minus 1 by root 3. Substitute the values ln 2a minus 3ut. Substitute time, that is ln 2a. Send minus sign inside, you will get 1 by root 3 and ln a by b. That is ln 2a by 2a minus 3ut. There, that is the angle rotated as function of time t. Check. So first of all, you should know what is happening with that circle thing. Like, what are the two components doing? The u cos 30s are bringing it together, and u sin 30s are rotating. From there, you got omega. So we went from kinematics to circular motion, then calculus. This is what makes this problem in advance. The paragraph 1. In kinematics, what we learned was a simple one, right? Find the time taken for them to meet. That was the easiest one. Do check out the steps, and that integration is, you should definitely mug up this integration. Comes a lot. Yeah, great. Let's see one more. Turn in the page. Devika, your cam is blank, right? So do try that problem again on your own. Now, you want to try now. The best thing to do, what you know what? Suppose if this was a square, remember I taught you this problem also square. Can you find the angle rotated by A? So that is how you try. So you can try and check what you got. Let's say we have a ring here. This is a fixed ring. Radius R. O is the center. On top of this, we have a rod, which is going with a constant speed U. The rod slides on a ring with speed U. So we take this point P. So P is the point of intersection between the rod and the ring. So P is not exactly a point, it is just a imaginary one, which is the point of intersection of the ring and rod. What do you mean by that? Think about it. I'll just draw a diagram here. So let's say initially rod is here, then rod comes here, then rod comes here. So how is point P moving? So initially P is here, then P is here, then P is here. So isn't P moving along the circle? You're getting it? So P is just an imaginary point, which is the point of intersection. So P is moving. So that means at any time T, if you look at this, this is your theta. Find angular velocity of point P. So P is a point of intersection of the rod and the ring. So these are the kind of questions, seventh one and fifth one. These are all similar type of questions. 5, 6, 5, 7. Did everyone get the question what I'm asking? So P is not a point on the rod, P is not a point on the ring, it's an intersection. So as the rod is moving, the intersection is moving. So find the angular velocity of the intersection. I hope you can see here clearly. Initially it is like this, now it is like this, now it is like this. So that thing is rotating. P is rotating in a circle. That's what I said. Whenever someone says angular velocity, don't think about a circle. If theta changes, it's angular velocity. The radius need not be constant. Anyone not clear with the question or the diagram, please ask. Question is clear? Go ahead. I'll give you 2 minutes. Kaushambi, Kritik, question is clear, na? Yeah. Let's see. See, the idea is this thing. Even if you see in question 5, that is what we did. You wanted omega. So somehow, if I can find theta in terms of x, and if I can differentiate it, I'll get omega. So here, this distance is x, and this is your radius r. So you tell me, when the rod is going forward, what is changing? X is changing. So what is dx by dt? Dx by dt is equal to u. Agreed? Because when the rod goes forward, x is becoming bigger and bigger. So dx by dt is u. That is how you see what is u exactly. And then from here, we can see cos theta is equal to x by r. Differentiate on both sides. Differentiate with respect to time. So cos ka differential will be minus sine theta d theta by dt. That would be 1 by r dx by dt. Since omega theta is decreasing, omega is minus d theta by dt. So always, differentiate and check whether the quantity is increasing or decreasing. Look at here. When the rod goes, is theta becoming smaller, isn't it? It doesn't matter. If that is a confusion, forget about it. Just take magnitude. And you know how is rotating? It is rotating clockwise. So minus sign will come automatically. Right hand thumb rule. But mathematically, that's what we say. Function is decreasing, then it is minus d theta by dt. See here, I wrote plus dx by dt. Why? X is increasing. Suppose if the rod was going left, even then I would have written dx by dt is minus u. So just keep that in mind. But it really won't matter much most of the times, but better you know. So this guy would be sine theta. This will become omega, and that will become u by r. That's it. The u by r sine theta. So the main idea is get the theta in terms of x and then differentiate. And if you see, that's what we did in this rod problem also, isn't it? We got theta in terms of x cos theta x will be differentiated. Have a look at this. Let me ask you one more like this. Clear? Any doubts on this? Mridul? Pramiti? Clear? Tanish? Next one. So we have a hemisphere. And we have a rod like this. This rod here, it is fixed. So the left end of the rod is fixed. This is theta. This is radius r, and this hemisphere is going with speed v. So the rod is resting on the hemisphere. Find angular velocity of the rod. Meaning, just think about it. Next moment, what will happen? The hemisphere will go like this. Then won't the rod become like this? Doesn't that mean the angle changed? Does everyone agree here? When the hemisphere is going, the angle is changing, the rod is coming more and more down. That means the rod is rotating. Next moment, when the hemisphere comes here, the rod becomes like this. So that means the rod is rotating. Find the angular velocity of the rod. Again, this is also like the previous question. Only thing, I'm just changing the way I'm asking the question. But in all the questions, the game is the same thing. You have to get the theta in terms of x, and when you differentiate x, you get velocity. Try. I'll give you 2-3 minutes. Anyone still didn't get the diagram, please ask me. What do you need to understand the diagram, Kritik?
Just could you explain it once more?
Why? What happened when I was explaining? What were you doing? Busy sometime.
No, so your voice was cracking actually, so I couldn't get that.
Then focus. You are distracted a bit. So initially the rod was like this. The next moment, what will happen? This guy will go like this. So the rod is still fixed on the left hand. Now the rod becomes like this. So can you see the rod is moving, right?
Yes, sir.
Theta is changing. So that was the question. Find the angular velocity of the rod. Sure, diagram is clear now.
Yes, sir.
Basically, as the hemisphere goes forward, the support is coming downward. So the rod will start coming down. Eventually, what would happen? The hemisphere would go like this, and the rod would just fall on the ground like this. Make sense? Yeah. Give it a try. One more minute. And others, please be on time for the class. We have to call you and then wake you up, and then you guys come to the class. It's not right. And if you miss the starting part, you won't be understanding. We did a pretty good problem in the beginning. Try. I'll give you a hint. See now, this rod here, this will be the tangent to the hemisphere. That means from the center, if you draw a line, this will be 90 degree. Makes sense? So this will be radius r, and this will be x. Again, x. So what is cos theta? How to get x into the picture? Now remember, this is the hypotenuse, this is the opposite side. So sine theta is r by x. Okay, na, differentiate and you're done. Now can you try? I'll give you a minute. So it is always about forming a triangle. The rod, since it is lying on the hemisphere, it forms a tangent. And tangent from the center, the angle is 90. Try. नहीं कृतिक, that's not the answer. Devansh वो भी नहीं है answer. X is not given, right? Devansh, X is something which you assumed. आप answer X का terms में you can't say that. You only know R and V and theta bus. Let me show you. Question is the same format, but this is a little more complex differentiation. So when you draw from the center, this is R, this is X. So we get sine theta is R by X. Now if I differentiate this, you're differentiating 1 by X, everyone. Sine ka differential is cos theta d theta by dt. That is r d by dt. You're differentiating x power minus 1, which is minus r by x square dx by dt. Isn't it? X power n ka differential, n is minus 1 here. So this would be cos theta d theta by dt is again minus r by x square dx by dt is v. But what is x? X is nothing but r by sine theta. I don't want x in the answer, so this will be omega rv cos theta. X is nothing but r square by sine square theta. V by r, that would be sine square theta by cos theta. Or you could have done like this also, x is equal to r cosecant theta, and cosecant theta ka differential. That will be cosecant theta cot theta, if you know that. In case you don't know that, then you can do this way also. That is also another good way to do r cosecant theta, and then differentiate. Dx by dt would be r minus cot theta secant theta d theta by dt minus cot theta cosecant theta. You have to use cos by sine theta and use f of x by g of x. So this will be v r cot theta cosecant theta omega. We get omega is v by r, cot becomes tan, and cosecant becomes sine. You can do this, but by chance cosecant theta click nahi hua, this works. V by r, sine by cos becomes tan theta, and 1 sine theta becomes sine theta. Check. The moment you wrote this, physics got over there. Then it is just a matter of math. Please check. So question 8, question 7, and question 5 all are similar models. What you're differentiating is changing, but the idea is the same. Do have a look at the steps. Next thing. Why did the minus sign disappear? Remember, यहाँ पे भी theta change हो रहा है ना? That's what I said. Whenever theta decreases, omega is minus d theta by dt. ना, as rod comes down, theta change हो रहा है ना? Clear with this, everyone? Next one. So that is a bit about omega. And then we have angular acceleration. So we have angular position, which is like x. We have angular velocity, that is like v. And we have angular acceleration, which is like a. So angular acceleration alpha. This is nothing but rate of change of angular velocity. So alpha can be written as d omega by dt. This just looks like dv by dt. This can be also written as omega d omega by d theta. Remember v dv by ds? Acceleration has two forms, dv by dt and v dv by ds. If you want to find alpha average, which is nothing but omega final minus omega initial by time, it exactly looks like acceleration. Delta omega will give you integral omega dt, alpha dt, So this is area under alpha t graph. Similarly, omega final square minus omega initial square by 2 is integral alpha d theta. So if you take area under alpha and theta, this will give you v square minus u square by 2. In case you have issue with the graphs, you should definitely go back to kinematics and check out. We have done all these graphs. So alpha t graph, omega time graph. There are 3 graphs which are there in this. Alpha theta graph. So area below the axis is negative. In an omega time graph, the slope d omega by dt gives you, just like in a vt graph, slope gives you acceleration. Here you get alpha. Area above the time axis is positive. Check it out. We had the exact same graphs in AT, acceleration time graph in kinematics. So all the graphs you learned, I can get the same graphs. Only thing x becomes theta, v becomes omega, and a becomes alpha. Check it out. Next one. Next one. Now, if you take it a step further, you can relate to exactly like kinematics. If alpha is constant, then you can use all your kinematics equations. Omega final is omega initial plus alpha t. That is v is equal to u plus at. Omega initial into time plus half alpha t square. This is s is equal to ut plus half at square. Omega final square minus omega initial square is 2 alpha delta theta. This is v square minus u square is 2as. I hope everyone's in the resemblance. And now, if you try to look at the relation between angular and linear variables, we have done this before already for the v is equal to r omega. So if this is theta, this is radius r, and this is your arc length. We know s is equal to r theta. If you differentiate this, ds by dt is r d theta by dt. This gave you v tangential. Be careful, v tangential is not the full speed. There can be also v radial. The vector form would be v tangential bar is omega bar cross r bar. If I differentiate this one more time, dvt by dt is r d omega by dt. This becomes acceleration. This becomes a tangential is r alpha. So again, a tangential bar vector form is alpha bar cross r bar. So there's also something called a radial. We will see. So acceleration also can have two components, one towards the center and one along the tangent. There, have a look at this. These are the vector forms. This is the relation between linear and angular variables. Any doubts on this? Clear? Any doubts on this? Anyone not clear with anything here, please ask. Let's see a question. Can I go ahead? Everyone? Achita? Clear? Archana? Arush? Aditya? Great. Next one. So we have a fan. A fan rotates 240 revolutions per minute clockwise. And has angular acceleration pi/4 radian per second square anti-clockwise. Find the total angle rotated in 50 seconds. Did you ever do this thing? Like, I don't know whether you have done this or not. Your fan is there. Let's say your fan rotates clockwise. This is what I used to do. I used to take the broom and I used to rotate the fan in the opposite direction and then go and switch on the fan. Kabhi kiya? You guys are good kids, right? And ऊपर से I think phone भी आ गया ना. You guys didn't have anything to do such kind of nonsense stuff, I guess. That's what I was saying. Since we didn't have phones and all, we had to do all weird kind of stuff to entertain ourselves. So if you see your fan, right, it rotates in one direction, right? So if you take a broom or something and rotate in the opposite direction and then switch it on, what will happen? So first it will continue to go in the same direction, but it will slow down, slow down, slow down, slow down, stop, and then it will go in the opposite direction. Is that making sense? So this fan will continue to go forward, but it will slow down, slow down, slow down, stop, and then it will go in the opposite direction. So that is what is happening with our question here. Initially, fan is rotating clockwise, but then the acceleration is anti-clockwise. So eventually, fan is going to stop and rotate backward. So find the total angle rotated in 50 seconds. Is the question clear? Give it a try. Think for a minute, then I will tell you something, then I'll give you a minute more. But first, you try to have an opinion for yourself. Clockwise, anti-clockwise thing. Nothing. It is going in one direction, then it starts See now, your velocity is forward. Think of like this. You're going forward, but acceleration is backward. Isn't it? What is clockwise, anti-clockwise? Just like when I say right and left, clockwise, anti-clockwise are two opposite directions. So the fan is initially rotating in one direction. Then because the acceleration is in the opposite direction, it will come back. So just to give you an idea, right, it is a little confusing when you want to see in terms of circle. So we can actually convert this problem, into a 1D problem. Think of like this. Think of, we have a vehicle here which is going with a speed u and acceleration a backward. Do you remember this problem in kinematics? How will this go? This will go forward and then it will take a turn and then come back, isn't it? So same thing is happening here, but it will be a little difficult to understand this because it is going in one direction clockwise, and then the fan stops because both the things are in the opposite direction, and then the fan starts rotating anti-clockwise. Making sense? It is going in both the directions. Now everyone, the catch is this. The trap in the problem is, tell me one thing. If I rotate forward 60 degrees and if I rotate backward by 30 degrees, how much did I rotate? What is the total angle rotated? 60 plus 30, right? It is not 60 minus 30. So if you use the formula delta theta is omega initial into time, what do you get? You get angular displacement. You won't get angle. So total angle rotated is similar to distance problem. That means whether you rotate forward or backward, it will always add up, isn't it? The question I didn't ask you find angular displacement. I said total angle rotated. Means you rotate forward or backward, I have to add the total angle. So total angle is similar to distance. So this problem, right, is we can convert this problem into kinematics and solve. So let me show you how to do that. Because tell me one thing, does Max really care whether you call it V or omega? Max will simply say it is a variable. Why do I care? So we can treat this thing to be a 1D problem. And this is what I'm going to do. So we have a block here whose velocity is u. Now be careful. Omega initial, it is given 240 revolutions per minute. That is not an SI unit. You have to convert into radians per second. One revolution is 2 pi radians. 1 minute is 60 seconds. This is 8 pi radian per second. We have to use this, everyone. If you had used 240, you're trapped. That is the reason I messed up the units wantedly. I gave revolutions per minute here, I gave radians per seconds per here. So be careful with that. Units have to be radians per second. That is your SI unit. That is the first thing. There is a chance you might have goofed up. So be careful. The second thing, so I can treat this as a velocity, u is equal to 8 pi. I can treat this as an acceleration, a is equal to pi by 4. So how will the motion look like? It will go forward. Then somewhere here it will stop, v is equal to 0. So we are going to the equation v square minus u square is 2as. V is 0. This is 8 pi whole square. 2 backward is minus pi by 4 into s. This would be 64 into 2, 128 pi. That means this fan will continue to go forward. It will rotate 128 pi clockwise. Is that making sense? And then it stops. Now, if I use the formula s is equal to ut plus half at square, be careful. This gives you displacement. This does not give a distance. So this is 8 pi, time is 50 seconds, plus half a is minus pi by 450 square. This would be 400 pi minus 2500 by 8, 1250 by 4, 300, 312.5 pi. or 87.5 pi. That means after this, tau, look at this thing, be careful. This is your displacement. And what is displacement? Distance between initial and final position. Means somewhere here, at t is equal to 50, you're here. You calculated this value, 87.5 pi, you calculated this value, isn't it? You calculated from the initial position, the fan finally 50 seconds mit reached here. You found this part. I don't want that. What I wanted is this one, which is 128 pi minus 87.5 pi, which is 40, 12.5, 40.5 pi. This is your anti-clockwise. So this is the whole story, everyone. The fan initially rotated 128 pi clockwise, then it turned back 40.5 pi. So the total angle will be 128 pi forward and 40.5 pi backward. If you subtract them, you'll get angular displacement. You want angle rotated, you have to add them. So you can convert this problem into simply a one-dimensional problem and solve. And doesn't this look like we have done something like this? This question, remember? Find the distance traveled in 15 seconds. The body is going forward and coming back. This was the question I was talking about. Remember this question, everyone? In S is ut plus half at square, S gives you displacement. But question where they ask distance. Whenever they say the word distance, have some fear. It's a trap. Because particle, when it goes and comes back, displacement is not equal to distance. Here, see, we got displacement minus 75, but in reality, this thing traveled 125. Is this clear, everyone? Any doubts on this, please ask. Please have a look at the steps. Kritik, clear with this? Anjali? Pramiti? Anyone? Next one. Anything you're not convinced, please ask. So you can convert, the circular motion problems, right? Whenever they ask you something like this, how much angle it rotated, what is the speed and all. See, Max doesn't care whether you call it x or theta, v or omega or a and alpha. So just because you already know how to do kinematics, do it in that form. It will be more convenient for you. Clear? Next one. Let's see a few more. Theta is t cubed by 3 minus pi t square by 2 plus 60 plus 1. Find the angular acceleration when omega is 0. Straightforward, people. These all are, calculus problems, differentiation and integration based. And in case you're confused, that is because you're not revising note stuff properly. Look at this question. Same question. X is t cubed by 3 minus 5t square by 2 plus 60 plus 1 plus 2. Find velocity when a is 0. You have to put a find acceleration when v is 0. There's no difference. It's simply a differentiation problem. Try. I'll give you a minute or two. If you differentiate once, you get omega. Differentiate 2 times, you get alpha. Right, Arush. We have an answer. Others, try. You got an answer? Do type in the chat box. Right, Devansh? So first thing, omega d theta by dt, which is t square minus 5t plus 6. Alpha is d omega by dt 2t minus 5. So the question says, when omega is 0, t square minus 5t plus 6 is 0, we get time is equal to 2 seconds and 3 seconds. So indirectly question ये हो गया, find alpha when t is equal to 2 minus 1. Find alpha when t is equal to 3 plus 1. That's it. Easy. Next one. Turning the page. Now, if alpha is equal to minus k omega, k is some constant, initial angular velocity is omega naught. Initial angular position is theta naught. Find omega after time t. Find theta after time t. Now here you will need some formulas. Integral a power x dx is 1 by a e power ax. Integral dx by ax plus p. This I wrote already. 1 by ln ax plus p. And if you have something like ln a to the base e is equal to b, then you can write a is equal to e power b. That comes from logarithms. You will need this. Try. I'll give 3 minutes. This is pure calculus question. And the best part, we have done this. We did this in integration. Remember this question? A is equal to minus kv. देखा? Alpha is equal to minus k omega. Initial velocity. Find the velocity at time t. Same question. Try. Should I show you? Right, that's the first part. Let's see the first part. So we have alpha is equal to minus k omega. So alpha can be written as d omega by dt is minus k omega. Bring that omega here, minus k dt. Integrate on both sides. This will go from 0 to t. Yeah, this will go from omega naught to omega. This will become ln omega. Limits will go from omega naught to omega. This is minus kt. This is ln omega minus ln omega naught. That is ln a minus ln b. That is ln omega by omega naught is minus kt. So this would be omega naught e power minus kt. Make sense? You can send that exponential there and shift it. Then what? Once you got omega, again you have to integrate for theta. So omega is d theta by dt. So we get d theta e power minus kt dt ka integral. This will be limits theta naught to theta and 0 to t. This is theta minus theta naught omega naught minus 1 by k e power minus kt. Limits will go from 0 to t. This is theta minus theta naught omega by k. That would be e power minus kt e power 0. Be careful, e power 0 is not 1. I'll send the minus inside. This will become omega naught by k 1 minus e power minus kt. Check. Like I said, it's brute force. There is nothing with double integration and done. Do have a look at the steps. Clear? Next one. So that is about circular kinematics. So we saw theta, omega, alpha, and all that stuff. That's the first part of the chapter. The second part is a uniform circular motion. Turn the page. Any doubts on this integration? We also call this thing UCM. So listen carefully. Now, regarding circular motion, whatever you studied in school, just forget about it. Most of it was shit. So listen with an open mind. Forget about what is centripetal force, what is centrifugal force. Just forget about all those things. So if you got the idea what is exactly happening and what it is, you are done. Matlab, it's pretty easy. You'll draw an FBD, you'll put acceleration, you'll solve. Again, it starts looking like NLM. So in uniform circular motion, right, there's only one definition that we have. In UCM, the speed of the particle goes in a circle with constant speed. That's it. That is the only statement you have. That is the whole meaning of uniform circular motion. It goes in a circle with a constant speed. Now, based on this, we can start getting a lot of data. So first thing, from this, we can get a data. The acceleration of this particle is perpendicular to the velocity. Now, so everything that you are going to prove now, make a statement, you're going to prove it. Like I said, the only thing it is going with a constant speed in a circle. The acceleration is perpendicular to the velocity and towards the center. How do we know this? Let's prove it with an argument. For example, think about it. If the particle is going with speed u, tell me one thing. If it is not perpendicular, what other option you have? If it is not perpendicular, meaning either it is making an obtuse angle or it is making an acute angle. Does it make sense? If you're not perpendicular, either you make an acute angle or an obtuse angle. So now if you take this angle to be theta, this angle to be theta, you will notice the components. This would be a cos theta. This would be a sin theta. This would be a sin theta. And this would be a cos theta. So what is happening here? If you see, the acceleration and speed both are in the opposite direction. So what will happen to the speed? If your acceleration is opposite to speed, what will happen? Speed will decrease. So in this scenario, the speed will decrease. Here, a sin theta is in the direction of u, so speed will increase. But what did you say in the question? The particle is going with constant speed. That means your speed cannot increase, your speed cannot decrease. That means you can't have an obtuse angle, you can't have an acute angle. So what is the only angle you can have left with? 90 degrees. Make sense? So what happens here is the a sin theta changes the speed. So this is the first statement that we proved. Therefore, acceleration has to be perpendicular to velocity. In uniform circular motion. Have a look at this. Clear, everyone? Now, so a few things here. So in UCM, if you look at the velocity, and if you look at the acceleration, now they'll ask these just theoretical questions. In uniform circular motion, velocity is constant. True or false? In uniform circular motion, speed is constant. Velocity is changing. Why? Direction changes now. Velocity has magnitude and direction. So be careful. Velocity is changing. Speed is constant. Most people in a flow, na, they think velocity is constant. Every instant the direction is changing. Second thing, if you look at the acceleration, even the acceleration is changing. Why? Look at the direction. The vector's direction is changing continuously. Acceleration is also changing. Why? Again, the direction is changing. Magnitude remains constant. We'll prove that. And you can clearly see there acceleration is perpendicular to velocity at any instant. Every instant and not once, every time. Clear with this? Any doubts on this page? Great. Now, before going ahead, I want to ask you something. Tell me one thing. If I catch you and pull you, you'll come towards me, yes or no? Right? Now, sun is attracting the earth. Everyone agrees? If sun is attracting the earth, why is earth not falling into the sun? What? Simple thing. Sun is attracting earth. Everyone agrees here. Then why is earth not falling into the sun? Who is stopping from earth falling into the sun? What do you guys think? You can type your answer. Think, tell me, it's a important one. There is an imaginary opposing force. Just look at that word, what you said. An imaginary opposing force, meaning your statement itself told it doesn't exist. Someone will say it's a centrifugal force. You studied in school, centrifugal force is fictitious force, it doesn't exist. So who is helping earth from not falling into the sun? Acceleration. So how can an acceleration cancel force? Think. God force. God is actually catching the earth and making it go in there on the sun. So it is the God. What did you guys think till now? Since we are a science class, so we will not talk about God. So who else? Kepler. He has no job only. Kepler is standing there and is making it rotate. थोड़ा time छोड़ देंगे तो you'll see Newton also is there. Newton is catching the earth and pulling the earth from going around it. Let's see what is happening. Listen to this thing. What's happening is interesting. We will just use our basic kinematics to prove this. So let's say a particle is going in a circle with speed u. Consider a very small time t. Okay. Now, just now we proved the acceleration is downward, velocity is tangential, the radius of the circle is r. Now you tell me, in very small time t, how much will the particle fall? The particle will fall downward. S is equal to ut plus half at square. In the vertical direction, there is no velocity. So this will fall half at square. Agreed? In a very small time, it will fall a vertical distance of half at square. Similarly, in the same small time, the particle will also travel distance ut because of horizontal velocity. Now from here, this is your center. If you take this, this is r. then this distance will be r minus half at square. Using the Pythagoras theorem, we get r square will be equal to ut square plus r minus half at square ka whole square. Expand this. R square, u square, t square plus r square plus 1 by 4 a square t power 4 minus a r t square. R square goes off, 1 t square also goes off. You end up with u square minus a r plus a square t square by 4. Since we said the time is very, very small, t tending to 0, this is 0 since time is very, very small. That means the figure which I drawn, I exaggerated it a lot. In reality, if you look at this will be so small, you won't even notice it. It's too small. So from here, we get u square minus a r is equal to 0. We get a is equal to u square by r. What is the meaning of this? So this is what is happening. So the answer to that question is, if sun is attracting the earth, why it is not falling into the sun? The answer is, the earth is always falling into the sun. There is no one stopping the earth from falling into the sun. Then what is happening exactly? This is what is happening. Every time the sun pulls you, the earth goes toward the sun, but the velocity is putting you back on the circle. Again, the sun will pull you, you fall toward the sun, but the velocity puts you back on the circle. You fall, again you put back on the circle. You fall, again you put back on the circle. And so on. Now, this happens so minutely, you won't even notice it. So there is no one actually balancing the earth. Earth is in an unstable equilibrium. There's no equilibrium. Earth is an unbalanced force. Is that making sense? So there is no centrifugal force, nothing. That means if I stop the earth for a moment and leave it, what will happen? It will go right into the sun, right? If I just stop the sun and leave, what will happen? It will go straight into the sun. Suppose if the sun suddenly vanishes, then what will happen to the earth? It will go in a line, isn't it? The reason you're going in a circle is because sun is pulling you. Meaning, your logic dekho na. If the sun is not pulling you, then the acceleration will be 0. That means you'll just go straight, isn't it? Is this making sense, everyone? You can't say that. V tangential C, velocity cannot cancel force. You're saying, if I apply a force of 10 newtons, if I give a velocity of 2 meter per second square, it is subtracting. It is not countering or something. There is a force, no one is canceling the force. This is what was happening. Every time you fall, getting it, you're getting back on the circle. Think of like this. If you look at Earth, looks, this is what happens. See, Earth, for every 8 kilometers, Earth goes down by 5 meters. Okay, that is the Earth ka curvature. That means if you fire a bullet with a speed of 8 kilometers per second, you know what happens? In 1 second, S is equal to half at square, half gt square. The particle will fall 5 meters down. But during the same time, it will also travel 8 kilometers horizontally, means the bullet will be exactly on the Earth's surface. So what happens is, the Earth and the bullet, right, both are there. You know, as the bullet is going, the Earth is also curving with the bullet. Getting Arush? Both the surface, the Earth is not flat actually, Earth is curved. So every time the bullet tries to go down, the Earth is also going down with you. So something of that sort. You're always coming and falling back on the circle. Let's see, write some statements. So the answer for that question is this. So when I said the Earth is falling into the sun, who is stopping? So the answer is no one is stopping. The Earth is always falling into the sun. There is no other force. Other than gravity. We can say it gives you an illusion. See, Arush, if it was cancelling out, shouldn't Earth just stay at the same place? It is going, na? It is not at rest. Other than gravity, Earth is not in equilibrium. But due to its velocity, it gets back on the circle. Now, this does not happen for every possibility. This happens specifically when you satisfy a certain condition. This happens only when a is equal to u square by r. So if a particle goes in a circle with speed u, and if you can maintain an acceleration a is equal to u square by r, you will go in a circle. What happens if I give more or less than u square by r? Can I turn the page? Now see what happens. If I give a is greater than u square by r, again, going back to the circle, you have more acceleration but less speed. Means what? You will travel more toward the sun, but you'll travel less horizontally. Agreed? Means you won't get back on the circle. That means the particle will go smaller and smaller and smaller and smaller. You'll spiral in, and eventually you'll collapse into the sun. What if acceleration is less than u square by r? Means you will fall less toward the sun, but you will go more outside. That means the particle will eventually go out, it spirals out. Is this making sense? So if you want to go in a circle, you have to have acceleration u square bar. You can't have more than that. You can't have less than that. Is this clear, everyone? Clear? Next thing. I'll see. So let me write the final statement here. So listen to the statement carefully. So if a particle wants to move in a circle, it has to have an acceleration. It needs to have an acceleration. How much? It needs to have an acceleration of u square by r. This we just now proved it, huh? Sorry. Now this acceleration rate just won't come out of free. Someone has to produce this, which has to be produced by an external force. This force is called centripetal force. Now, the centripetal force is not some new kind of force. So any force that will help you to go in a circle is called a centripetal force. Now, this can be tension, gravitation, friction, all your standard forces. Tension, friction, gravitation, etc. So catch kya hai na? This is the misconception people have. People, you know what they think? Since you're going in a circle, there'll be a force. It is wrong. It is other way around. You will go in a circle. If you want to go in a circle, there should be a force. इसीलिए तो circle में जा रहे हो. But generally, people think this way. Since you're going in a circle, there must be acceleration. Are you getting the catch? If you go in a circle, you won't generate force. You have to have a force, and then you will go in a circle. And this acceleration is called centripetal acceleration. Centripetal towards the center. Clear? So this is given by A centripetal is V tangential square by R. This can be also written as omega square R because V tangential is R omega. And this we proved. We just didn't get it out of thin air. So for example, when this Earth was going around the sun, the one who is making you go in a circle is gravitation. For example, if you tie a block of mass m and if you make it go in a circle, again, the reason you're going in a circle because there's a tension in the string. So tension is centripetal. So centripetal force is not a new force. Anyone that helps you to go in a circle is called centripetal. Is this clear, everyone? So this was the whole theme in the chapter actually. So anything that goes in a circle, so we will say there should be an acceleration. So when you when you solve a problem, you choose a system, draw the FBD, SI and accelerations, write equation, solve. It just starts looking like NLM again. So is this clear, everyone? So if you want to go in a circle, there should be an acceleration. If you want acceleration, there should be a force. That is the story. But normally what we think is you are going in a circle, the force aa jayega. Did you ever feel it? You're going in a car, and when the car is taking a turn, it feels like someone is pushing you towards the door. You know, actually, what is happening in reality? What is happening is this. See, suppose if the car is here, and let's say there is no door, okay, and you're sitting here, and let's say the seat is smooth. So you're going forward, car is also going forward. Now the car starts taking a turn. So what will happen? After some time, the car will be like this. But remember, your velocity is still going forward. So when the car makes a turn like this, you'll be out of the car. Isn't it? In that Singham movie, he does na, he comes out of the car like this only. He comes fast in a car, takes a turn, and he just walks out. But what happens now? There is a door, isn't it? So because there is a door, you'll go and hit the door, and the door will start pushing you inwards. So you get an illusion, अरे मुझे कोई push कर रहे door के तरफ. But what is happening in reality is you're going, the door is coming towards you. Is that clear, everyone? Now let me show you how this looks. So that was the main thing there. This is actually a game. It's called Universe Sandbox. You can actually create your solar system here. And if you can see here, that is our galaxy. You can zoom in, you can check the sun. You can do a lot of interesting things. So that is the sun rotating. And you can see the orbits there. There is Earth. So that is sun. That is Mercury. That is Venus. That is Earth. Hope you're able to see the Earth. Now see, just now what did I say? So if I stop the Earth, you can actually change the data here. There, see. So I make Earth ka speed here is right now 30.3 kilometers per second. If I make it 0, and see what happens. If you just stop the Earth, it just goes straight into the sun and gone. Did you notice? And now look at the Mars here, okay? You can see the Mars and other planets here. All are going in a circle. Now what will I do? I'll switch off the gravity. There are options like that. You can play a lot. So in this thing, right, you can see the bottom option. Now you tell me what did I say just now? If sun suddenly vanishes, what happens? There is no force. There's no centripetal acceleration. You'll go in a straight line. Agreed? Now if I switch off the gravity, look at all the planets. So what happened? Everyone just goes in straight lines. If you just zoom out, you can see the planets are just escaping. I can speed this up. You can see it faster. Can see how all the things are going away from the sun? There. They all just will go off in a straight line. If you switch off the gravity, that's how it looks like. Because you have a lot of other models also. You can create a lot of simulations on this. I think these are all planets, I guess. No, anyway, it's a good one. That the name of the game is Sandbox, Universe Sandbox. Did you see how everything just went away in straight lines? That way, if you stop the Earth velocity, it just goes straight into the thing. That way. If you suddenly turn on the gravity now, again it will get attracted. Now they won't go in circle, they'll go in actually ellipsis. We will see that in gravitation chapter. That is one. Next thing, let me show you another one. This is from a movie.
First time in your life, Wesley.
So this is our hero there. So hero is being trained to shoot bullets at curves. Getting it? There's a movie called Wanted. There's some picka thing. So there is a target behind that flesh. So he has to curve the bullet around that thing and shoot it. But unfortunately, he can't do. So the heroine says, I'm standing in front of the bullet target. Can you see the target behind? So you have to shoot a bullet which will go around this heroine and then goes and hits the target. So this is not our Wanted, wo Salman Khan nahi hai. This is an English Wanted. And same thing if you do this thing, the scene in Bollywood, to they say, yaar, South Indian movie copy kar liya. So there he's going to shoot. And this guy shoots, the bullet goes, and can you see how it is turning? Bullshit. That is bullshit. That bullet would have hit the girl and the girl would have died. Movie would have ended there and story khatam. Now look at that bullet, what it does. It goes and then it turns again inside and then hits the target behind. There, it's in the bullseye. So this is nonsense. Getting it? That can't happen. A simple question. If the bullet is going to take a turn, there should be a force. which force is making the bullet turn? The bullet is going like this and like this. So there should be a force which is pulling inside. Bullets can't turn like that. Once you shoot, they'll just keep going. Maximum what they can do, they can go down because of gravity, they can come down. You can't go left and right. If you want the bullet to go left and right, you have to put some rockets or something on it. It's like a missile, then it's not a bullet anymore. So that is a big blunder. It doesn't work like that. But then again, movie, if you should see the climax of the movie. That's even great. This heroine shoots a bullet, it goes in a circle and kills everyone in a circle and comes back. That was even highlight actually. I couldn't find that scene. When I was looking at the movie and thinking, yaar, in log ka circular motion aata nahi hai. So there, even English movies, right? They do shit things. Right? We appreciate like, yaar, itna technology, they think a lot of science and all. Not all. Even they do some shit movies. Anyway, so that is the point of it. So the main idea of this uniform circular motion is this. So if you go in a circle, there'll be an acceleration called u square by r. Clear? So once we know that, now next class when we catch up, we're going to do problems. Idea is the same. Step 1, choose your system, draw the FBD. Step 2, assign accelerations. You will assign u square by r. Step 3, resolve forces, write equations and solve. That's it. The only new thing you learned in this chapter here is u square by r. Then it looks exactly like an LM. Clear? So on dosa, we added potato, it became masala dosa. Now we are adding onions, it becomes onion masala dosa. So we are just upgrading that same dosa. Okay, so with that, we'll wrap up for the day. And then next class, when we catch up, we'll continue from here. We'll be doing a lot of numericals on this. So those are doubts.